quick audio check on my side. Can people hear me okay?
Yep.
Hey, Dan. Hi, Hannes.
Hey, Dave. Hey, on.
Mohammed, I saw your question in Slack. Been in meetings all day yesterday. I'll see if I can still dig somebody up or figure out what the right point of contact is for you.
Okay, we can give people a couple more minutes to join.
So who is Trio Zoom today?
What?
Somebody signed in as Trio Zoom. I'm just wondering who that is.
Oh, that might be me. I'm Derek Miller with ARM. Just a sec, I'll show up. See if I can. I'm from a conference room that I haven't used before, so yeah.
Thanks, Derek.
There we go. I was just going to say I haven't seen Hans yet in order to present first, so I can at least wait for that, but just saw them join now.
Hello, this is Hans. Can you hear me?
Hi. Yes.
Yep.
Thanks for joining us.
Yeah.
Okay. We are 2 or 3 minutes in. I think we could probably go ahead and kick things off a little bit. Kind of logistical things. Well, last week we had mentioned that we thought this week we'd be doing the analysis of the presentations that we've seen over the last 3 or 4 meetings. However, a couple new topics did pop up. We have Hans here to talk about HTTP-A, attested HTTP, and then also I think we have some on EAT, and how it relates with TLS.
It's Hannes.
TLS. What's that?
Hannes is going to present that.
Oh, okay, great. Here is the agenda doc. If people that are on the call now want to hop over there and add your name as an attendee, and then also Tomas, if you could add the presenter's name in there as well for that second topic, that would be great. Let's see, I guess we can go ahead and get started. If anybody is joining at this point, they can pick up the presentations as they are when they join. So I think, was it Dan wanted to give Hans an introduction?
Yeah, just a brief introduction. I'll let Hans mostly introduce himself here, but we've asked Hans Wang from Intel Labs to come and present some of he and his cohorts' work on adding attestation into the HTTP protocol. And with that, I think I will hand it over to you, Hans, to introduce yourself.
Yeah, thank you very much, Dan. Just first step, just want to make sure my microphone is clear to everyone.
Yeah,
Yes, we
it's
can hear
clear
you
for
great.
me. Thank you.
Cool. And at the same time, I'm also sharing my screen, so let me know if you couldn't see it. Okay, my name is Hans, and I'm an AI research scientist from Intel Labs. My research of interest is mainly focused on a variety kind of the security privacy AI problem, including federated learning, privacy preserving machine learning, and adversarial machine learning, etc. And also I kind of believe those private AI techniques have strong implications for Intel confidential computing platforms, which also motivate me to come up with this idea with Gordon as a contributor to this presentation as well, to talk about the HGPA. And I'll talk about the motivation later about why kind of AI research scientist has something to do with this communication protocol. Right. And before I get started, I want to also mention Gordon King. He is a cloud software architect from the Intel cloud computing security platform team. And with his contribution, so I'm able to make this talk and then have a discussion with everyone. Okay, so I think I want to share this idea which come from my last year experiences in the Ice Lake launch demo and the incubation activities I did in last year for the confidential computing businesses. And I just want to share some of the ideas for L7 protocol, which I call that HTTP A1. A stands for attestable and HTTP just HTTP protocol. Attestable kind of algorithm or kind of the protocol that we want to integrate the attestation to be used for the AI services. And so this talk, I want to invite feedback and then see if any ideas or contributions, potential collaborations that we can probably talk about that later in the future. And just a notice, today I'm talking about the HGPA1. That means actually, we are also working on the HGPA2 based on the feedback we collected from the customers. So today's talk, I will also talk about the feedback we collected last time and see what's probably briefly mentioned what we're currently working on for the HGPA2. But because this is still in legal review, so I will just stick to the HGPA1 version, which is already published, and we can start from there to have a discussion. All right, so I'll quickly talk about the outline, background, problem statements, and of course, I'll briefly go through the HGPA1 protocol and then Amazon's approach. But I think today I will not talk about this, and I will talk about the summary later. Okay, so this goes back to my last experience in building trustworthy federated learning system for Intel Ice Lake demo and the FL product. So as you may know, trusted distributed private AI system, regardless of the federated learning architecture or student-teacher architectures, are becoming one of the hot topic that we want to provide the users with the privacy security guarantee. And one of the fundamental questions is how can we attest or trust remote AI services? While the AI services is becoming powerful, leveraging a lot of big data and extract insights, how can we be convinced that they are trustworthy and to submit our data for this service? Okay, and then another kind of motivation comes from the customer feedback that were collected by Gordon, that Gordon was engaging with the customers to enable SGX type of the application for years. And then their experience in the remote attestation system is that they found this is pretty important, but this is pretty hard to use. And to some degree in practice, this is also that costs a lot of time and effort to maintain too. So then we kind of want to know whether we can figure out a way to reduce such a dependency on those complexities and trying to build and maintain this remote attestation system to serve the L7 applications. And lastly, we also noticed there are great demand. It's probably getting bigger and bigger that more companies trying to provide their trust type of the services by using remote attestation system based on the TE or different kind of hardware TE to to convince their users that this web service is trustworthy. And then, so potentially they want to make the internet trustworthy, and we have many different ways. So we're thinking, why not we can have a unification way for the L7 application to achieve that. So with those motivations, we kind of start thinking and then building this HTTPA build, trying to integrate the remote attestation on the to the L7 application as the final endpoint rather than L5 endpoint. Right, so this is the kind of the internet background. So when we're thinking about whether this is a crazy idea, we want to take a look at the history, whether to make sure that maybe someone has already done this or no one has done that, and maybe we can export it. So as we know, HTTP has evolved over time from enabling just a web communication and equipped with the security features by using TLS. And then for HTTP 2 and 3, Google has enabled it with a lower latency and then reduce the transmission errors, so on and so forth. And look at this, well, I think probably one of the future for HTTP to evolve is probably the trustworthy part. And that is something we think it's interesting to explore. Okay, so I think most of you here have already familiar with HTTP and HTTPS. So here I just want to highlight that HTTP is a channel transactional protocol, and by using the request response between client and server, and HTTPS equip that by using the TLS to equip the HTTP protocol with the more security feature, including the authentication, confidential communication, and the authentic data integrity. And if we can have all of them on the L7 applications for example, for the AI service to attest each other, that'd be a great thing. But currently we don't have that. So we are thinking maybe HTTP8 here can help from this perspective. Okay, so before I talk about the problem statement, I want to talk about our assumptions. We kind of believe that TE-aware services will be one of the popular things in the future that will take care of the confidential applications if people care about the data and their privacy. And as we know, we don't need to wait until the future. Now we already have a lot of third-party software vendors plays important roles in this current web ecosystem to take care of our data and the privacy stuff. And we have to trust them. Another thing is the workloads running on the cloud and for cloud computing are vulnerable to the host and vice versa. And besides that, we have also stronger demand over time driven by software services, or as we can see, emerging AI applications is trying to dominate the market as well, to automate a lot of things with some intelligence and customer services. And that requires more microservices and L7 load balancers to facilitate those network performance to provide the best user experiences. That's happening. And then, however, the thing is that it seems to be a trade-off. Whenever we're talking about the performance, we have sacrificed some of the security things here. And this is no exception here. In many HTTPS communication, TLS terminates at the application gateway or L7 load balancers. That's a fact now. And while the cloud computing infrastructure is getting larger and larger and more complex, this becomes hard to manage, and it may impose security concerns of vulnerabilities, of course, leading to a lack of confidence and trustworthiness. It's hard for us to have confidence to trust the end-to-end communication of the modern internet now. What's our current solution here? Yeah, this is HTTPS. This is something developed by probably 2 decades ago. It currently provides us with the secure channels, but it may not be enough to protect the web services for building the trust. And then, as we know, big players are proposing their own solution to build trust as well. So that means now we are thinking about probably we need a certain standardized approach to simply extending the existing protocol to build a trust for using web services. And this is the HTTP attestable, what we are trying to propose. That we hope this can target establishing trusted end-to-end communication with the attested endpoint for HTTP communication. So here's just some example about the industrial URL routing and the load balancers. As you can see, TLS termination happens in the gateway, and however, attack surface between the gateway and the backend servers is increasing over time. It's totally different from 2 decades ago, while the infrastructure is getting more complex. And usually passing the gateway from the internet, traffic flows unencrypted to the backend servers. As you can see in the AWS example case on the left-hand side. And then if you want to reduce the attack surface, you can also initiate a new TLS connection to backend, as you can see on the right-hand side of the Azure case. This can mitigate the risk, but it doesn't touch the root cause that the channel is no longer trusted. It is already untrusted after the TLS termination. And actually, it's the same thing. It's probably the common thing for TLS termination to happen for the performance purposes. For example, Kubernetes ingress also assume TLS terminations at the ingress point, and that can make it perform better. And it is a dilemma between security and performance we have to deal with all the time. To improve the performance, we have to sacrifice some security. From this degree, we look at this problem, it seems to be the yes answer. But why not we try to explore that from a different angle? Okay. Then here is the HTTP. So we're kind of thinking the problem, approach the problem from a different way, that before we think about the endpoint in terms of the L5 or L4, usually L5. And then now we're thinking, why not we think about the endpoint, which is the L7, that is the final endpoint we're interested in, the application. So in this plot, L4 layer guarantees reliable connection between host level endpoints, however, it is not secure. And L5 layer, people add TLS components to guarantee confidential communication with PKI kind of approach for authentication. However, the certificate is ambiguous sometimes as to why the cert is certifying almost everything behind that host level endpoint or the hub. Now, if the host refers to a single person, then obviously it can be associated with that person's identity. But what if there's a big commercial organization or like infrastructure? It's just a big, it's not a point. It's no longer a point. And L7 layer at which is application itself located in this context, we to denote that as an application level endpoint. This endpoint is something different that is also computational. This is also for the computational purposes. And in order to establish trust between applicational level endpoints, I think it's the most meaningful thing for us, especially for AI applications. We need attestation to assure the identity of application for verification, and on top of that, trying to build a trusted connection. That means, but here we try, what I mean by trusted connection is the secure communication between the attested endpoint at the L7. And this is just a quick overview. I will just quickly go through HTTPA at this point. Today, I expect to spend 20 to 30 minutes, so try to be as quick as possible. HTTPA stands for HTTP Attestable. It is an HTTP extension. And HTTP message on the right-hand side, as you can see, it consists of 2 parts. One is the header, one is the body. And HTTP message is based on the HTTP message format. In addition, it has trusted session ID in the header that is associated with a certain TE resources and encryption signing features for its specified components in the body. So those security features can be achieved by using T ephemeral keys produced by HTTPA trusted handshake that we'll briefly cover later. Okay. And on the left-hand side, it is where the web service is sitting at. This is a diagram showing HTTP over TLS, what it looks like. As you can see from the left-hand side is HTTP inside the internal network and go to, when we go over the application gateway to the outside, it will be encrypted by the TLS wrapper, just like right hand side, and then go to the internet. And then backward, once we pass the application gateway, L7 application gateway, it will be decrypted into a plain text HTTP message. And note that the gap between the web service and the application gateway is increasing. And if we have this HTTP kind of the confidential computing at L7 level, we don't need to worry too much about the application gateway effect that will lose our privacy on the sensitive information. So for example, for the HTTPA level, we can encrypt the message and we can sign the message. So anything happens between the web services and the application gateway, we don't need to worry too much about that because we can still believe that this kind of L7 end-to-end security is still protecting the HTTP messages at this point. Sorry, any question? Okay, thanks. Yeah, so in order to achieve L7 secure communication for the sensitive information in HTTP messages, how do we build a trust between endpoints? Which is L7 endpoint, not L5 endpoint. So attestation mechanism comes into play. We want to make sure how we can build a test kind of approach to have a tested endpoint that we believe that is trusted endpoint in this context. So as you can see, attesters want to test itself to the remote client who can verify those assurances and decide whether to trust it or not. So that tester here is the web service, and on the right-hand side, we have relying party and the verifier sitting on the client side. And note that the relying party and the verifier can be separate entities, but it can be one entity, depends on the implementation. And eventually the client has this freedom to decide whether they want to trust those statements of the assurances provided by the attester, and then reject the service if they want to trust it. That's kind of freedom we want to provide. Okay, so this is a HTTPA handshake. This is for the HTTPA 1. With HTTPA 2 will make it a little bit different in the contents. So here, I think that's just what rather than go to each details one by one, I will just give you a high overview on this handshake. Basically, it is on top of TLS handshake in this example that we have 3 important stages. The first stage is the HTTP preflight request response to make sure you have a TE service of TE awareness capability or not. And the second thing is a HTTP attest kind of phase things. And inside this step, we have HTTP attest transaction request and response, and HTTP trusted session request and response for the secret provisioning. And that's it. And after that, HTTP attestation handshake will build the trusted communication between L7 endpoints. So after this handshake, we'll achieve 4 things. The first is the attestation process will be finished. And the second thing is the key exchange that will both parties will share some ephemeral shared keys or secrets. And the third thing is that we'll have a trusted session establishment between the endpoint. And the last thing is the secret provisioning that's needed. Okay. Okay, this is HTTPA over TLS. So here we show the trusted end-to-end channel on top of the TLS connection for the HTTPA. WAs on the left-hand side stands for the web services on the and the middle part is the gateway. On the right-hand side is the client users. So as you can see, between the web services and the gateway, the HTTPA kind of traffic and the TLS channels, they can be multiplexing and multi-connections happens there to make it also efficient. And then on top of all those attest the endpoint, the secure communication is not just at the L5 level, but also it can be improved. It can be raised to the L7 level between the final web service and the client, regardless of what happened over an intermediary point between them. Okay, so and TLS termination is pretty popular. This is the slide I want to address why people care like that. And then I think you know it very well. And okay, I saw someone raise your hand. So do you have any question?
Yeah, I just wanted to ask, like, is it only that the attester is being attested by the service, or can this happen in both ways, where this service server can be attested by the attester? Is it a mutual attestation or one-way attestation?
Right, that's a good question. So in HTTP also support the mutual attestations. So if the client can provide their quote and then provide their kind of quoting information, that can be verified by the server, and server has that right to request that as well. So yes, they can be done in mutual way for sure.
Okay, thank you.
Yeah, thank you for the question. Okay. Yeah, so I think this is TLS. Most people have been very familiar with it, so I'm not going to dig in further. But anyway, it is a good tool for people to use it to boost the web serving experiences. Okay. With HTTPA, we can still have that happens. We can still enjoy the same web experiences with the TLS terminations, but we still can protect the sensitive information inside the HTTP messages. That's a goal. So in these pictures, you can see HTTPSA traffic, which means HTTPA over TLS. Okay, HTTPSA traffic go through the many different intermediary nodes, terminators, load balancers. It could still be the HTTPSA traffic to the endpoint, or it could be a plain text HTTPA traffic. However, the HTTPA confidential message is still protected by the TE encryption at this point. So the user can ensure that L7 level security and trust to a certain degree. Yeah, so HTTP also support the mutual way that if it's needed. And how do we do that? How do we implement that for the web service? There are simply 3 steps. First, we assume hardware TE in this context, and so that I can generate a code to be verified. And then we can implement a TP extension to support HTTPA, and also implement the browser level plugins to support the HTTPA protocol as well. So the POC of that, it shouldn't be hard. Okay, so these are the benefits. I just want to quickly go through it. HTTPA can help you to verify some identities on the identities of the web services, including the software services, vendors identities, and the TE identity itself. And also it can establish the TE-based end-to-end trustworthy channel at the L7 level or the application level. That HTTPS connection is used in between, and also the remote attestation and secret provisioning can be done. And most importantly, thing is that it can leverage the TE for the confidential computing, which is to ensure not just the communication security, but also execution security. And I think eventually what we want to enable is that this is the kind of freedom for each individuals, that they can control and process their own secrets and reject the service they don't want to trust. And with this protocol, we can unify all those different remote attestation and make it, be more usable and universal in a simple way to serve people. And okay, so I'm going to the end. So this is the feedback we collected from the customers on our HTTPA1 versions protocol, that some customers think they want a perfect forward secrecy. That is not. In this case, it provides a certain degree of perfect forward secrecy, but it's not strong, it's weak. So we want to recommend ECDHE for HTTPA1, which we are doing for the HTTPA2. And customers want both high security and good performances. So we also want to recommend ECDHE. And the implication here is that if this is a secure communication at L7 levels, do we still need TLS? Okay. This is a pretty strong questions that I cannot answer yes or no, but this is pretty interesting direction that we want to explore as well. Okay, and complexity. That now we can use HTTP to reduce the current complexity. That we don't need to assume additional layers for doing remote attestation. People who are familiar with the web services, who are familiar with the HTTP, they can take advantage of that by using HTTP extension to do this. So the complexity, we think it is lower than other kind of possibilities by adding additional layers. And the scalability that currently, I think, we cannot say this definitely scalable. We need implementation to prove that. But we know that some feedback from customers that the way they are currently doing is not scalable for them. So they think this is probably one of the candidates that they would like to try out for the better scalability. So to some extent, our next version of HTTP 1, which is HTTP 2, has addressed most of the concerns above. So this is a kind of quick tables for comparison between the HGPA and the RTLS and HTTPS. I think we have a lot of them, but one thing I just want to point out, I'm not going to go through all of them, but I'm going to point out one key difference is that this is about the question whether this is better served at L7 or L5. So if we have some remote attestation mechanism happens at L5, it has to go with every update configurations with TLS. And that would definitely involve some software levels kind of complexity to update, upgrade, and validate. Okay. But if you're interested in this, all those details, you can check into the table later. And probably that's it. I would just go through the summary. I know I'm running out of time. And so HTTP is an L7 protocol based on HTTP extension for internet and to facilitate attesting web services based on hardware T. And then also HTTP ties secure communication to attestation context for L7 application. And we are envisioning this would be a kind of industry standard candidate that we can enable confidential applications in the future that can accelerate that transformation towards trustworthy internet. So that's it. Thank you, everyone. Yeah, I saw someone raise your hand. Hi, Kate.
Yeah, so I at a high level, I think this is pretty similar to the STEP protocol that I presented a few weeks ago. With the STEP protocol for what is here the HTTP encryption that happens at the L7 layer. We just used another TLS another TLS session. You kind of tunneled in there instead of having its own kind of a scheme for encryption. And then that's how we addressed some of the feedback you'd gotten on like perfect forward secrecy and everything. Just using TLS at another layer to accomplish that. I would point out, you also mentioned that, do we really need TLS on the outer layer? And at least in our case for STEP, we decided that it still did have value there because you can have a certain amount of authentication that happens on the HTTP session that the load balancer may want to accomplish. And it would need to have access to that information in order to do so. And you would need to be able to trust it and still have the encryption involved. So I think it is a good discussion to have, but I think that there is still probably some value that could be had from having TLS on the outer part of the session as well.
Yeah, that makes sense. Thanks.
Okay.
Yes, yeah, please.
So you were talking about extending the HTTP and the standardization work that goes into that particular aspects of the protocol. So you're going to have to probably register new methods, new headers, new content types, and especially regarding the introduction of new methods and new verbs in HTTP. It can be tricky. So I wanted to try and understand what is your strategy here, whether you've already started discussion with the stakeholders. So I'm thinking that the HTTP-BIS working group in the ATF as the main reference point for this kind of discussion. This is especially the introducing new verbs is not going to be cheap. Other have tried and have unfortunately failed. So maybe one alternative to that would be to look at providing a RESTful API to do the initialization based on standard verbs, and then when you have that state exchange, when you have the session established, then move on with the rest of the protocol. Just random thoughts, but thank you thank you very much for the nice presentation.
Also, I have a comment as well. So just a little bit of background. So I was personally very, very excited about token binding back in the day. And the bank I work for was actually vehemently opposed to it, despite obvious, advantages. And the reason is that it broke their capability of break and inspect. And as much as personally I hate the break and inspect, it becomes a control requirement for a regulated institution to be able to basically interject itself in the middle of any TLS traffic to be able to do the necessary level of traffic inspection and monitoring, and there's any number of things. But assuming everything else about this proposal is beautiful and stellar, you would need to address how somebody might effectively inject a reverse proxy into the flow.
So somebody inject what to the proxy?
Reverse proxy, basically the ability, you need to be able to basically transparently to the endpoint inject it yourself into the middle of the flow, like it's done with the reverse proxy today.
Oh, I see. Yeah. So I think I'm not familiar with the detail of the reverse proxy, but I know they will inspect some information from the HTTP messages. So at this point, if that part of the message is not encrypted, I think maybe that would be fine.
I mean, the question is the requirement for a monitoring of the reverse proxy, or are they injecting packets into the protocol?
Well, I would have to double check. At the very little, we need to inspect. So when they don't say break and modify, they say break and inspect, right? So and this happens when, for instance, you monitor traffic for signs of data exfiltration, right? Or I mean, whatever you might want to do, but secure communications inside a regulated institution that cannot be monitored by a man in the middle are effectively off the table.
I did notice in the presentation earlier that it looked like there was two modes of the HTTPA kind of extra authentication and on the inner packet. There was encrypted and then also just signed. I wonder if the signed mode would accomplish what you're mentioning, Mark, because it would still be inspectable. It just wouldn't be confidential to the load balancer or to the gateway.
Right. Well, in that case, we need to run the gateway confidentially as well. I mean, ultimately, you want to preserve the confidentiality of traffic, right? But it is also very important to be able to do your own monitoring.
Right. The confidentiality may have to rely on regular TLS on the outer session. And then with the only extra value add of HTTPA would be end-to-end integrity. I think.
Yeah. So you're basically saying there's a confidential compute node, which is providing the monitoring capability while also providing sort of end-to-end confidentiality for anybody else that's outside of that outside the community that's trusted.
Yeah. So ultimately, whoever is doing traffic inspection is a trusted entity, but we need to maintain confidentiality with respect to everyone else. But any attempt to remove this trusted entity from ability to inspect the contents of the traffic basically runs afoul of our regulatory obligations.
That's a great point to bring up. I think we'll need to maybe defer more of that discussion until we go through our analysis. I'll make a note in our notes. I think I'm going to go ahead and call time on this one, though. I want to make sure we leave some time for our next presentation. Tomas, did you want to give Hannes a quick introduction?
Oh, well, Hannes needs no introduction. He's a great guy. He's a colleague of mine. He's a distinguished engineer in ARMA. He's author of around 100 RFCs. He's been active in the ATF for years in privacy, security. What else, Hannes? I don't know. You know, real time, IoT, you name it.
Yeah, thank you for giving me the opportunity to present here. Actually, a topic which we started some time ago with Matthias Bossart, who is also on the call. In this IDF draft, it's an individual submission. Let me put that in full size. So the idea back then was the following. Like the previous presentation, obviously for remote attestation, you need to send the attestation, the evidence around and to a remote party. And so there are obviously lots of possibilities to do so in different layers, and conveying that information in different layers obviously has different properties. And so we, for the work we had been doing in the RATS working group on the ETH token, we obviously were interested in passing that information around. And we wanted to do it lower in the protocol stack, since that allows us to provide, first of all, use, in this case, DLS for its reuse most of the properties, so we don't have to rebuild them at another layer. But also because DLS is so widely used in a number of places, not just on the web, but also for IoT devices. It's used for inside network access authentication, so you can actually do the attestation already at the time when you attach to a network, for example, in an enterprise Wi-Fi network that uses the EAP protocol. And so we were wondering on how to do that. And like Hans, I wanted to provide a little bit of history on why we got there, because there's some precursor to the work that we're actually utilizing. And I will cut it short because of time. You know many of the historical aspects of the web. And the most important point here is that there's some work on a TLS extension called RC 7250, which introduced raw public keys, and also it added a way to negotiate an additional new certificate format, because obviously an e-token or like not everything is an X509 certificate, let's put it that way. And in the meanwhile, there's some other key types registered already as well. Won't go into those details because they are not relevant for this debate here. So we are using this established mechanism without actually using the raw public keys themselves. But these extensions, if you're familiar with the DLS exchange, essentially every new feature in DLS is introduced by this client hello, server hello exchange, so that both parties actually agree on the use of it. And it's the same is done here, of course. DLS 1.3 adds another facet to this by utilizing the so-called encrypted extensions, which allows you to encrypt some of that information that would have otherwise been sent in clear in the server hello. I'm sure you're all familiar with the benefits of using DLS 1.3 over 1.2 with the better privacy features and the better performance it has. And so there are two extensions in this RFC, in the 7250 RFC, namely the client certificate type, which is colored in green here, and the server certificate type, to indicate what the client is able to either indicate in case of the client certificate type, or what is expected or what it is capable of processing. Obviously, both make a difference because there are a couple of different combinations possible in terms of attestation, like who is attesting what to whom in that combination. So it could be the client to the server only to the client, or it could be both parties use these attestation capabilities in a mutual fashion. So those that's why there are these two extensions rather than maybe just one. And here's how this looks like in an example. Taking that from that RFC, the numbers indicate like these new sort of newly introduced extensions. It's pretty straightforward if you are familiar with the DLS handshake, which among these security professionals here and on the call, I assume it needs not a lot of explanation. So in this case, the scenario shows the DLS server using raw public keys, and I will later have a similar example, but just with the attestation information, which uses the same extension. So getting to this specific document, which is actually quite short, you can fetch it from the IETF draft repository, because it only adds a new value to that registry. So in that sense, standardization-wise, it's a smaller effort. The way how we wrote it allows special features of these CBOR web tokens to be used. And for those who hadn't been following the RATS IETF group, the CBOR web tokens are used for the entity attestation tokens. So the CBOR web tokens are the more generic versions. We thought that it would be useful to make it more generic, not just to focus on attestation. It makes, like, message-wise, makes no difference. And there's even the possibility to include, like the figure here on the right-hand side shows, to include the public key in that token itself, which it then would look like literally like a certificate, just in a different encoding with the claims needed for attestation. The encoding, the CBOR encoding, which what you see here is a diagnostic format, because we humans are not particularly great in parsing sort of binary values, of course. So it's that's this encoding, but the real message would be the binary format, the CBOR based format, and which is quite compact. Also conceivable, not listed in the or described in the draft, is to just omit the key and just have a key ID, which would translate more to, for example, our use of the BSA attestation token, which is another document that we've been working on, which is implemented in our trusted firmware M our implementation, which is used on IoT devices and Cortex-M microcontrollers. So just to reiterate how this relates to attestation, this specific draft, because CWT and EAT are not 100% the same. They are not 100% the same because there are a few other encodings in the EAT token which we are currently not utilizing and are not planning to utilize because they are size-wise. In case of the JWT, JSON web token, which the entity attestation token also allows to be used as an encoding. As the name says, it's a JSON-based encoding, which is quite verbose. So it appeared to be unnecessary for us to make the tokens artificially large. And UCCS is another variant, or another encoding variant that doesn't use a signature, which is also not something we want to use in our case. We also have been working on code. Or contributing to code. There's a popular implementation of CBOR called QCBOR, and the corresponding security wrapper for it called DCOSI. The links are here in case you are unfamiliar with those libraries. This was written by Lawrence Lundblade, who was a former Qualcomm employee who became a consultant, and he has done great work in creating all these implementations, and we've been contributing to his work because we think it's one of the best implementations out there. And it offers a flexible crypto backend, which allows us to nicely integrate it into our software ecosystem, which is also why we like it so much, needless to say. But it also supports OpenSSL, and you can hook in other crypto libraries if you want to. So now here's an example of how CWD would be used in such a combination with this with the previously mentioned extension. So in this case, what I wanted to do is to have the client providing the attestation information, and the server just using a regular X509 certificate and certificate chain. And this would be the setup in message part 1. You would just indicate what the capabilities of the client are. The server, if it supports those capabilities and if policy allows it, of course, it would sort of convey or echo these preferences back. And it would also give the client then the indication in 3 that the certificate message actually contains the respective payload. So in for example 3, it would be the X509 certificate, and the certificate request would then be the request for the attestation information, which is then echoed or sent in message 6. Lots of details, but I assume the slides will be shared anyway, so you can look at it. So over time, that's my observation, the interest in attestation has increased, specifically thanks to the work you guys are doing with confidential computing. Of course, in general, it dates back to much earlier days, but I think I see a lot of renewed interest and lots of excitement. So that's why we also have been writing up this document to just share our ideas. We still have to do some implementation work on based on what I had just shown. But in the meanwhile, luckily, there has been some advances in our code base. So the TLS 1.3 implementation, which we would use as a foundation for this, is available since end of last year in our embed TLS library. And also the DCOSI implementation that I previously mentioned has advanced quite a bit. So it's first of all stable for the digital signatures which we would need here, but also it's the testing that the tests the library has gone through and its support has matured. We are planning to prototype this the document that I talked about in using embed TLS. And if anyone is interested to either join us for this for the specification work that still needs to be done, and for prototyping, you are more than welcome. And that's all I have. It's quite short.
So, Hannes, last time I checked, the Rust ecosystem for CWT, CBOR, and all of that was not great. Have you checked lately, or is there any work in that direction?
Yeah, actually, so there was recently an IETF meeting in Vienna, and there was a hackathon, and I noticed that a number of people worked on Rust and CBOR libraries. So I can double check with them and ask them what library they have been using. Maybe Hank, we were sitting next to them, but I didn't dare to ask them what library they were using.
So there is a lot of things incoming. The libraries I'm aware of are Rust, Golang, and .NET. So probably Rust is the one that is interesting to things that are more constrained. But on the server side, I also know Verizon, for example, uses Golang. So I think both is interesting. Talking about COSI specifically.
Yeah, I can ask and send a message to the group. There was also some people who have been not for COSI but for embed DLS. They used a wrapper, a Rust wrapper around embed DLS. So yeah, I need to check.
Was going to make some of their stack public. That is EAT based, and so there's COSI support and stuff like that, and that's Rust.
Mm-hmm.
Who is that again?
Global platform. I think it's Jeremy.
Okay, nice.
I can get in contact with him if you need. Yeah.
Yes,
Right.
I think
Yeah, so
we have been talking to them, and think they are working on open source Rust implementation.
Yeah.
COSI library.
So this is Hank. I am as Jeremy is a co-author of mine, I am aware that the governance process of global platform is not the fastest, and that is the prime inhibitor. So if you look at the activity of the TPS, it's a long name, of the global platform, trusted platform services implementations, I think GitHub, random, there's just one commit or something like that, because there's hundreds of commits inside global platform, and they have to create a release that goes public. So that's the current government process. So it looks like a relatively slowly moving GitHub project, but in fact it is moving, but they can't expose it in that manner today. So that's the governance, I want to say, challenge. Yeah, at the moment with GP, with the global platform. Sorry.
Thanks. Who is actually moving or managing the queue here? It's not me, right? Supposed to be the chairs, or
I don't know. My hand is up for you for a totally different reason. My hand is up for a question.
Me too.
So I don't know who was
Dave
first.
was up. I think Dave Thaler was up first.
Okay.
So my question is actually generated from your example slide, maybe one back or two back or whatever. I had the arrows going back and forth, where you showed CWT in one direction, X509 in the other direction. Often in attestation, we talk about mutual attestation. It seems to me like you should be able to do the same thing for the server certificate type 2 and use CWTs in both directions, correct?
Yes, that's correct. I just picked this example because
yeah. No, I think it's a fine example because it illustrates the full, the flexibility that whether it's the server type or the client type or both or neither, right? It could be any of those, right? And so if you're doing, say, an IoT, a constrained device, a constrained IoT device that wants mutual attestation, then you probably would want CWT in both directions. So just want to point that out. All right.
Yeah.
Can I go?
Yeah, Thomas.
So I have a curiosity. How you deal with freshness in the CWT? Is it seeded by the client and server random from the TLS session, or is it something else? And that if that's something else, I wouldn't know where to
Yeah, that's correct. So that's also a point that I think needs some elaboration in the security consideration section of the document. That's why, despite being more or less just entry in a registry, I still think that it needs the specification needs some extra work and description. So it's definitely, I mentioned it's an individual submission. So like many of you are familiar with the IETF process. So it's still like it's a contribution. This is not
yeah, the specification is currently for CWT. As Anders mentioned, we need to add a section for EAT and any kind of attestation that would kind of specify that for how the recommendation for using EAT as part of a complete attestation process.
Yeah, I think it would be easier for the reader. Like I personally like the more generic approach, but then sometimes the readers actually will miss the key point in all in the generic nature of this. Yeah.
So we are nearing the top of the hour. I wonder if we can take Hank's question really quick and then do some logistics for next time?
I am never quick. Sorry. Hi, thank TLS. So when you say certificate, it's a TLS certificate, I assume. So I love that certificate and CWT are in the same rule here. Apparently, I would be a very large proponent of that. Then I hear EAT, which is not a certificate, and attestation. So I think they're two very separate things. I think both are relevant in this context. And if you need help establishing a certificate type that is comparable to X509 in CWT space, you found yourself a contributor here right now.
So the point of the specification is that when it says certificate, instead you have a CWT token that includes the POP section for what is the public key.
For the public key of?
Well, of the party, so either the client or the server.
So that raw public key could as well as be the content of a X509 certificate.
When you have the type, X509, you have an X509 certificate. When you have the type CWT, it's a CWT with proof with POP, which means a public key. If it is type equals raw public key, you have a raw public key.
Okay, I understand that, but you are bordering on setting a very important precedence here, and that is equivalency of certificate encodings. And if you're aware of that, and if you want to go through with that, I would like to have.
Cool. Yeah, that's a great offer. Thanks, Hank. Definitely.
Because that is a wall breaker, right? You're doing something unique here, and in the scope of TLS, but it is relatively significant, I'd say.
Yeah, it's definitely also a simpler certificate format in that sense.
Yeah.
Well, which is also nice, like for some of our use cases, like often people talk about high-end use cases, but also for the low-end use cases, you obviously don't want to be provide a lot of complexity implementation-wise, and also not size-wise on what goes over the wire.
Yeah, and I'm gonna quickly echo Dan's comment in the chat. I think this is a great conversation. We do have our Slack channel. I think that we could continue that momentum there. I think people are going to start dropping off very quickly here since we did hit the top of the hour. So thank you very much, Hans and Hannes. These were great presentations. If I'm not mistaken now, I thought this last time as well, but I think next time we will be ready to start discussing some of the the important attributes of the different presentations we've got, some pros and cons of each, and really start discussing about what direction we want to go as a standards body, or not as a standard, but as a SIG in creating an example of how we kind of recommend accomplishing this sort of thing. With that, do one of the other chairs of the SIG want to sign up for next week organizing that discussion?
Yes, why not?
All right, sounds good. So in 2 weeks.
Now? 2 weeks. Okay. So.
Yeah, in 2 weeks we will plan on, unless anybody comes up with new things that need to be discussed in order to have that conversation. I think in 2 weeks we can have our kind of compare and contrast.
Yeah. Well, I volunteer,
Okay.
but unless Greg or anyone else wants to, prefers to have the.
I'm good with you taking a couple weeks from now.
Okay, cool.
Great. Thank you, everybody.
Thanks
See you
very
in 2
much.
weeks.
Bye.
Thank you all.
Have a good day. Bye.
Thanks, everyone.